Hey everyone, this is Bhargav Suthar, and today we are going to continue with the recurrence relation. Now in this today's session we will discuss examples of non-homogeneous recurrence relation. Now in previous session we discussed 2 or 3 types of the right hand side. Now we will discuss the rest of them. So what is a non-homogeneous linear recurrence relation? Let's recall that. So again, if the right hand side is not equals to 0, then it is called a non-homogeneous recurrence relation. Then its solution will be called a particular solution. Now what is the general solution? The general solution of non-homogeneous linear recurrence relation, it is called a total solution. So the total solution, it is the addition of homogeneous solution and a particular solution. Now that is AR equals to AR raised to H plus AR raised to P. So homogeneous plus particular. Now particular solution for given RHS. In previous session we discussed 2 or 3 types. So we will discuss first f of r, that is right hand side, and the form of or choice of particular solution. Now see, if right hand side equals to d raised to n, some d raised to n, then we will select p d raised to n or p n d raised to n. If this p d raised to n fails, then second case, now an exponential form. If right hand side the exponential form is db raised to r, and provided this b is not the characteristic root, then we will choose a particular solution as this pb raised to r. And third case, an exponential function, this db raised to r, that is same, but here this b is the characteristic root. In previous type, if b is not a characteristic root, then we will select pb raised to r. Now in this, if b is the characteristic root with the multiplicity m minus 1, then we will select a function like this, p r raised to m minus 1 and b raised to r, that is, and m minus 1, it is a multiplicity. So let us discuss examples. Find the general solution of AR plus AR minus plus 5 AR minus 1 plus 6 AR minus 2 equals to 42 4 raised to r. Okay, so as you can see that the right hand side is not equals to 0, so it is a non-homogeneous equation. So we need to find a particular solution as well as a homogeneous solution. Now first we will find a homogeneous solution. So for homogeneous solution, let us write what is a homogeneous equation. So just put right hand side equals to 0, then we will get a homogeneous equation. So that is AR plus 5AR minus 1 plus 6AR minus 2 equals to 0. Now the characteristic equation. So here the order of the equation is, so that means k equals to 2. So the characteristic equation. So the characteristic equation will be alpha square plus 5 alpha plus 6 equals to 0. So it is a quadratic equation and we all know that how to solve it. So the alpha will be minus 3 and minus 2. So what will be the solution? The homogeneous solution will be like this. So ARH, that is A1 minus 3 raised to r plus A2 minus 2 raised to r. As they are distinct roots, so the solution will be like this. So this is the homogeneous solution. Now for the particular solution. Now for the particular solution, consider the right hand side, that is f of r. Here what is the right hand side? The right hand side is 42 into 4 raised to r. So the solution will be like this, p 4 raised to r, because this 4 is not a characteristic root. So that is AR will be p 4 raised to r now. So that means AR minus 1 will be what? This p 4 raised to r minus 1. Just replace r by r minus 1. And in same manner, AR minus 2, that will be p 4 raised to r minus 2. Now substituting the values of AR, AR minus 1, AR minus 2 in the given recurrence relation. So what we will get? So p 4 raised to r plus 5p 4 raised to r minus 1 plus 6p 4 r raised minus 2 equals to 42 4 raised to r. Okay, so we need to just solve this. Now see, p 4 raised to r. Here we have 5p 4 raised to r minus 1. So 4 raised to r minus 1 can be written as 4 raised to r divided by 4. So that is what we are doing. So 5 by 4 into p 4 raised to r plus 6p 4 raised to r minus 2. So that can be represented as 4 raised to r divided by 4 square. So that will lead to 6 by 16 p 4 raised to r, that is equals to 42 4 raised to r. So now see, all the terms are of 4 raised to r, so just we are taking LHS So that we will get 21 by 8 P 4 raised to R, and that is 42 4 raised to R. So now we are just comparing the coefficients of 4 raised to R. So in left hand side we have 21 by 8 P, and in right hand side we have 42. So the P will be 16. Okay, so P will be 16. So hence the particular solution will be like this 42 into 4 raised to R. And hence the total solution will be AR equals to ARH plus ARP. So the addition will be like this. So let us discuss second example. Find the general solution of AR minus 3AR minus 1 minus 4AR minus 2 equals to 4 raised to R. Now see, again this is a non-homogeneous equation, so we'll need to calculate both the solutions, that is the homogeneous solution as well as the particular solution. So for homogeneous solution, again the homogeneous equation will be, just put right hand side equals to 0, so that will be AR minus 3AR minus 1 minus 4AR minus 2, that is equals to 0. Now the characteristic equation, here what is the order of the equation? As you can see, R minus 2, so just K equals to 2, so order of the equation will be 2. So the characteristic equation is, just start with the highest order, so alpha square minus 3 alpha minus 4, that is equals to 0. Now how to solve this quadratic equation? You know very well. So alpha equals to minus 1 and 4. Now hence the homogeneous solution will be like this. Both the roots are distinct, so we'll apply the first case for the distinct roots. So ARH equals to A1, just take alpha 1 as minus 1 and take alpha 2 as 4. So A1 minus 1 raised to 4 plus A2 4 raised to R. So this will be the homogeneous solution. Now for the particular solution, just consider the right hand side, that is f of R. So here what is f of R? Here f of R is 4 raised to R, but it is the form of a particular solution, is not P 4 raised to R as the previous one. Why? Because here 4 is the characteristic root. Okay, so that first case won't work. So since the characteristic root is 4, and how many times it is repeating? It is repeating only, or it is occurring only once. So the form of the particular solution will be this: P R raised to m minus 1 and B raised to R. Now that is P R raised to m minus 1, that is the multiplicity. So and the multiplicity is 1, so just simply P R and raised to 1, so simply PR, and B raised to R. Now what is the root? That is 4, so 4 raised to R. So the choice of particular solution will be PR 4 raised to R. Now so that means AR equals to PR 4 raised to R. So in same manner, just substitute all these values, that is the value of AR, the value of AR minus 1 and the value of AR minus 2 in the given recurrence relation. So what we will get? We will get this type of equation. Now just open the brackets. Now see, here you can see that 4 raised to R minus 1, it can be represented as 4 raised to R, divide by 4, so 3 by 4, so 4 raised to R, and in same manner 4 raised to R minus 2. Okay, so that can be represented as 4 raised to R, divide by 4 square, so that is 16. So here we have taken 4 by 16 and rest are same. Why we are doing this? Because we want to just compare the coefficients of 4 raised to R. Okay, so now comparing the coefficients of 4 raised to R, we will get 3p by 4 plus 2p by 4 equals to 1, and if you solve this, you will get p as 4 by 5. So hence the particular solution will be this 4 by 5, that is p R raised to 1 and 4 raised to R. So this will be the particular solution. So hence the total solution will be the addition of homogeneous solution and a particular solution. So this will be the final answer. Let us discuss last example. Solve this AR minus 4 AR minus 1 plus 4 AR minus 2 equals to R plus 1 2 raised to R. Now see, the corresponding homogeneous recurrence relation will be what? It will be this AR minus 4 AR minus 1 plus 4 AR minus 2, that is equals to 0. Just simply put right hand side as 0, so we will get this. Now what is the highest power here? R minus 2, so that means the characteristic equation, it starts from 2. So the order of the equation is 2, so alpha square minus 4 alpha plus 4 equals to 0. Now that is alpha equals to 2 and 2. Now what will be the homogeneous solution? Now here you can see that this 2 is repeating twice. Okay, so we will use that second type for the repeating roots. So the homogeneous solution will be a1r plus a2 and bracket 2 raised to r, because this 2 is repeating 2 times. So this will be the homogeneous solution. Now for the particular solution, just consider the right hand side. Here f of r. Okay, so here f of r, it is of the form what? R plus 1 and 2 raised to r. And also here you can see that 2 is a characteristic root with the multiplicity 2. Fine. Now right hand side is r plus 1, 2 raised to r, and also 2 is the characteristic root, and plus in addition it is multiplicity with 2. So the form of a particular solution will be what? It will be like this p0 plus p1r, this whole. Why p0 plus p1r? Because this r plus 1, it is of the linear form. Okay, so p0 plus p1r into r square. Why? Because it is of multiplicity 2, and 2 raised to r because 2 is the root. So the choice of AR will be like this. So now substitute the values of AR minus 1, AR minus 2 in the given recurrence relation. So we will get this type of equation. Now just open the brackets. So on simplification, I'm just doing directly. So on simplification, we will get 6p1 into r2 raised to r equals to r2 raised to r. In same manner, the second equation, and we will get, on solving these two equations, we will get p1 equals to 1 by 6 and p0 equals to 1. So therefore, the particular solution is p0 plus p1r. So that means 1 plus 1 by 6 r square and 2 raised to r. And hence, the general solution or the total solution, that is the addition of homogeneous and particular solution. So we will get this, so a1r plus a2, 2 raised to r, and plus this particular solution. Okay, so this will be the final answer. Thank you.